So in this video, we are going to solve a problem on equilibrium of planar forces. This is the problem number 2. A bar AB of 12 meter long and 140 Newton weight is resting on a smooth surface as shown in figure. Find the distance x at which a force of 60 Newton is applied to hold the bar in the position shown. So on the right hand side diagram, we have the bar AB is resting on a horizontal surface and an inclined surface. Both are smooth surfaces, and the inclined surface has a slope triangle 2 to 3, and the bar itself has a slope triangle of 4 to 3. To solve this problem, first we will take the free body diagram of bar AB and show what are the forces acting on the bar. For this, we need to calculate how much angle this inclined surface is making with horizontal. Similarly, how much angle the bar AB is making with the horizontal. So let's try to find out that before we proceed to the free body diagram. So if we can calculate this angle, so here the slope triangle, vertical is 3 and horizontal is 4. So we can calculate it. Let's call this angle as some theta 1, let us say. So we can write for tan theta 1 equal to 3 by 4, for which we'll get theta 1 equal to tan inverse of 3 by 4 is equal to 36.87 degrees. Next, let's try to find out theta 2 of the angle which the inclined surface makes with the horizontal. So that can be written as tan theta 2 equal to, this is 3 by 2, so from which you can calculate theta 2 equal to tan inverse of 3 by 2 is 56.3 degrees. Now let us draw the free body diagram of bar AB. Now there will be two reactions acting on the bar AB. One is at point A and the other one is at point B. So the reaction which is acting at point A is exactly perpendicular to the surface at A, and let's call that reaction as RA. So RA will be acting exactly at point A and it is vertically upward. Let me call this as RA. Similarly, let us take a reaction force which acts exactly perpendicular to this surface at point B. So for that, let us draw the surface at point B. So this is the surface tangential at point B, and now we have to take exactly perpendicular to that one. Now this is the perpendicular force acting at point B. So let's call this as RB. What are the other forces acting on the bar AB? One is the weight of the bar acting exactly at the middle of the length, so that acts vertically downward. So let us take this the midpoint of the bar AB. Now this force is acting vertically downward, and which is equal to 140 Newton. And there is one more force of 60 Newton acting horizontal, and so this is 60 Newton, and it is acting at a distance of x from point A. So these are the forces acting on bar AB. Now we are going to use force summation as well as moments about point A to find out what is this distance x. So first let us take sigma x equal to 0. Then we will take moments about point A. But before we apply force summation, we must find out what are the horizontal and vertical component of RB. Because RA is vertical, its horizontal component is 0. So that's why let us try to find out what is the vertical and horizontal component of reaction RB. So for that, let's draw a horizontal from the tail of RB, and then at the tip of RB we will draw a vertical to meet the perpendicular we have already drawn. So like this you can construct the right angle triangle. Let us extend this line, this vertical line, by some distance. We will draw one more horizontal. Now as we see from the previous diagram, the angle the smooth surface makes with the horizontal is 56.3. We have calculated that is theta 2 equal to 56.3 degrees, and so that means this angle here is 56.3 degrees, and we know this is 90, and because one is horizontal, the other one is vertical, and the total angle should be 180 degrees. So that means this angle here will be 33.7 degrees, and accordingly this total angle here is 90 degrees, so the remaining angle will be 56.3 degrees. Now RB has two components. One is this horizontal component here. Let us write that as RBX, and this vertical component as RBY. So we can take RBY here itself, but RBX, the convenient point of application is this point B. So let us draw. So this is the horizontal component, and so it's acting like this. So now this is RBX, and whereas RBY is this one. So we have two components, RBX and RBY. One is horizontal component, the other one is vertical component. Now if we observe the free body diagram, 60 Newton is horizontal, RBX is horizontal. Similarly, RA is vertical, 140 Newton is vertical, RBY is vertical. Later we are going to take moments about point A, so that the moment of RA about this point A will become 0. That's why we need not calculate RA. So if you don't want to calculate RA, the force summation which is better is writing force summation in x direction. So we are going to write sigma x equal to 0. So let's write sigma x equal to 0. So if you write sigma x equal to 0, there are only two forces, horizontal force acting, and one is 60 Newton, the other one is RBX. The horizontal force acting towards right is positive, so 60 Newton is positive, and RBX, because it is acting towards negative direction, x direction. So that means let us consider x and y coordinate system like this. So this is x and this is y. So 60 minus RBX equal to 0, and let's call this as equation 1, from which you can easily calculate RBX equal to 60 Newton. Now let us write RBX in terms of RB. So we know that RBX equal to RB is this force, and it makes an angle of 56.3 with the vertical. So we can write RBX is this force here, is the opposite side of that angle. So that is RB sine 56.3, from which you can find out RB. So RB you can find out RB equal to RBX divided by sine 56.3. So RB will be equal to 72.12. Now from this you can find out RBY, because RBY is needed when we apply the moment summation. So RBY is equal to RB. So RBY is this one, and it is adjacent to the angle theta, that is 56.3. So that will be RB cos 56.3 degrees, and accordingly RBY we can calculate 40 Newton. Now let us consider the moments about point A. So we will take a sigma MA equal to 0, and we will consider the clockwise moment as positive. So we can calculate what are the moments about point A. The first force is 60 Newton, and so 60 Newton is acting here, and its distance from the moment center is this distance here, and we can observe that this here, this is x, and so this will be x sine this angle. So this angle is 36.87, so this will be x sine 36.87. So we can substitute that here. So 60 multiplied by the distance, perpendicular distance, is x sine 36.87 degrees. So that is the moment of the force 60 Newton, and we can easily observe that the 60 Newton will have clockwise momentum. It tries to rotate like this, so there is a clockwise moment. Now let us take 140 Newton. So this 140 Newton will also have a clockwise moment about point A. So that is plus 140 Newton multiplied by its perpendicular distance is, now this is the line of action of this 140 Newton and this is the moment center. So we need this distance here. This is the distance we have to calculate, and so this distance is nothing but this total, this half distance of the bar AB is 6 meter. So this will be 6 multiplied by cos 36.87. Now so we can calculate, we can substitute this 6 multiplied by cos 36.87, and it has a clockwise moment. And two more forces, one is RBX, then RBY will have, both will have counterclockwise moments. One is RBX will have a moment like this, and RBY also will have moment like that. So both are counterclockwise, so negative. Then one is RBX, first one is RBX, so RBX multiplied by what is the distance of this line of action from moment center A. So let us extend this. So this is the distance we are trying to take, this distance here is the distance, and so that distance is nothing but the total length of this bar is 12, and this is the opposite side of this 36 degrees, 36.87 degrees angle. So this will be 12 sine 36.87. So RBX multiplied by 12 sine 36.87 degrees. Similarly, RBY will have counterclockwise moment. So RBY multiplied by its moment arm will be, so RBY is this length. This is the line of action of RBY. So let me extend this further, and the perpendicular distance from point A to this line of action is this distance. So this is nothing but 12 cos 36.87. So let's substitute that, 12 cos 36.87 degrees. And as we observe, there are no other forces that are having moments above point A, so this must be equal to 0. Now there is only one unknown in this equation, because RBX we have already calculated. RBX is 60 Newton, RBY is 40 Newton. So we can substitute those values into this equation and find out the unknown value x. So if we calculate like that, x will be equal to 4 meter. This is the required answer.